All right, so we're going to do another example. This one's going to involve completing the square. So if you don't remember how to complete the square, if you're struggling with it, go back and review the videos in the review video folder that I put in for this week. All right, now with this, I'm going to ask you to sketch this graph and label all of the key features. Well, this is not something you can type in the calculator because it's got x's and y's, and you can see trying to solve for y is not going to be the easiest thing possible, where you can actually then put it into a graphing calculator. So you're going to actually have some strategies here. So what I'm going to do is, I already know this is a hyperbola because I see a minus between my x squared and y squared, but I don't know which way it's facing yet. You would want to say, well, my y's first, so that means it's going to be vertical. But you can't make that assumption yet. You have to hold off until you get it in general form to figure it out. All right, so I've got to complete the square twice. And so what I'm going to do is I'm going to collect all my x's together by using the commutative property and the commutative property. And I'm going to gather all of my y's together. And anything that doesn't have an x or y, I want to put on the other side. So right off the bat, I see I have a 16y squared. And then I want to rewrite this as plus 64y. Then I have my negative x squared, and I have my 2x, plus 2x. I want to move this 64 to the other side, and that's minus 64. So all I did was just rearrange this using the commutative property and then subtracting 64 from both sides. Now we're almost ready to complete the square, but when I complete the square, I got to have the number in front to be a 1. So that's a bit of an issue. So I need to look and see, well, not even the greatest common factor. In fact, I just need to factor out that number. So I'm going to group these. I'm going to group my y's together, and I'm going to group my x's together. And I'm going to put a plus sign in between here. The reason why I do that is so I don't mess up my signs. So if this was a minus, put a plus a negative number and treat it that way so you don't mess your signs up. All right, so I'm going to ask myself, 16 and 64 have what in common? Don't take the greatest common factor. We just want to get the number in front of y squared to 1. Well, it has 16 in common. So I'm going to take a 16 out, and that leaves me y squared plus 4y. Here, a negative x squared and 2x. Well, all I care about is the number in front of x squared. It needs to be a 1. Right now it's a negative 1. So I need to take the minus out. So when I take the minus out, I want to get x squared minus 2x, because I have to take a negative out of the x squared. I have to take a negative out of my positive 2x. This is the only way to do it correctly, is minus 64. This is why I say do it this way, so you don't mess your signs up. Now I just complete the square on the inside of the parentheses. So I'm going to have 16 times y squared plus 4y. I'm going to take half of this term, which is 4. 4 divided by 2 is 2. I'm going to square it is 4, so I'm going to add 4. Now on this side, I've got my negative 64. I have to be careful. I didn't just add 4, I added 16 times 4. So I'm going to add 16 times 4. Now I'm going to do a minus, and I've got my x squared minus my 2x. I'm going to have to take half of my middle term, negative 2. Half of my middle term is negative 2 is negative 1. Negative 1 squared is 1, so that's plus 1. But I didn't add 1, I've subtracted 1 from this side, so I've got to subtract 1 from this side. You have to keep it balanced. Now from here, we can kind of clean everything up, and I'm going to get 16 times y plus 2 squared, because it's a perfect square trinomial, minus x minus 1 squared, perfect square trinomial, that's why we do complete the square, equals negative 1. I'm almost there. I'm almost to my general form. My general form has to have it equal 1, and I don't have any numbers in front. The numbers are on bottom, and they're squared. So I'm going to divide everything by a negative 1. That'll make this a positive 1. So that's going to give me x minus 1 is going to go from negative to positive squared. My positive is going to go to a negative minus 16 y plus 2 squared equals 1. All right, almost there. This is easy to see. This is going to be over 1 squared. This one is not easy to see. This is 16. I can do a nifty little trick. 16 is really, I can say it's 1 over 16 to the negative 1 power. So I can write it as a fraction. And then I can say this would be 1 over 4 to the negative 2 power. Now, how is that going to help me? Well, I need a square, and I need this. The negative means it's in the bottom part of a fraction. So I can rewrite this as x minus 1 squared over 1 squared equals, well, minus y plus 2 squared over 1/4 squared, because that's 16, because it's in the bottom of the fractions, the negative, right? And then the 1/4 squared, that's going to give you my 16, and then it'll come back out, equals 1. All right, so now that I've done all of this math to get it in the general form, I'm finally ready to answer the question, because this isn't even the pre-calculus. This is just really algebra 2. Now we're ready to do the pre-calculus part. All right, so let's do the pre-calculus part. What I would ask you to do is actually to graph this and label all the key features. When I say key features, what I'm looking for is the center, the vertex, there's 2 of them, and the foci. I'm not so much concerned about the equations of the lines going through. I just need all of those points in your graph to look roughly right and roughly having those in there, but I don't need the equations of those asymptotes. All right, so let's look and see what I have. I know my A, which is always my first term, is 1. My B is my second term being squared, which is 1/4. I don't know C, but I can find C because it's just Pythagorean theorem. And then I know my H is 1, and I know my K is -2 because it's plus, so we're doing opposite signs. So I already know my center of this hyperbola. I also know that it's horizontal, it's opening right and left, because my first term, the positive one being squared, is my x, so it's going to be horizontal because the x-axis is horizontal. All right, so I know my center. My center right here is going to be h comma k, so that's 1 comma -2. I know the distance from here to my vertex is a. So I'm going this direction because my x is squared. I'm going horizontally. So I'm going to go right. That means I'm going to add 1. This is going to become 2, -2. And I'm going to subtract 1. This becomes 0, -2. So there are my vertices, and they're labeled. All right, now I need to find my foci. Well, my foci is a distance of c. I don't have a c here, but I can find it because c squared equals a squared plus b squared. Well, I have an a and a b, I just throw it in the calculator. Or I just do it by hand, really. C squared is going to be 1 plus 1/4 squared. C squared is 1 plus, let's see, this is 1 over 16. C squared, when I add my fractions, I'm going to get 17 over 16. I take the square root of it. Square root goes to the top and bottom. I'm going to have my C is going to be plus or minus the square root of 17 over 4. Because the square root of 16 is 4. Square root of 17, we leave it square root of 17. Now, all that means is my distance from here, from my center, all the way over, is 17 square root 4. Well, the square root of 17 over 4. Well, what exactly does that mean? Well, I have 1. I have another point over here. I don't know what this decimal is. I don't even care. Just label it. This was going to be 1 plus the square root of 17 over 4, because I have to add from the center to get to my foci. -2. All of my y values, because this is horizontal, is going to be the same. Then I want to do the same trick over here. I want to subtract 1 minus the square root of 17 over 4, comma -2. They will get messy as you label them. I'm okay with that. All right, now we need to sketch it. Well, I know that there's going to be a point up here somewhere, and there's going to be a point down here somewhere. That distance is 1/4. So that is going to be 1 comma -2 minus, or this one's plus 1/4. I could calculate it if I want. I don't really care. It's just a sketch. Show me you know what you're doing. And then here, this is 1 comma -2 minus a 1/4. I am going to put in my rectangle. I want to go from my center out like it's a diagonal. This is just a rough sketch, so it does not have to be perfect, as mine is not perfect, and I'm not going to pretend that yours is going to be perfect. This is what I'm looking for. It does not have to be perfect. And then you're going to go from your vertex, and you're going to stay along the asymptotes. And there, ladies and gentlemen, would be the graph of it. If you give me this, it doesn't have to be precise. I know you know how to find the center. I know you know how to find the vertices. I know you know how to find the foci. I know you have the idea that you just do a plus a b and a minus a b. Draw it in from the center out through here. Your asymptotes are in there. There's going to be asymptotes that this has to stay in between, and voila, you're done. This is all I'm asking for. Nothing really crazy. All right, that was a fun problem. Now it's time for you to be able to do your own. There's practice on the study guide. Make sure you're doing the study guide so whenever you get to the exam on this, you're familiar with the type of questions I'm going to ask. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.